The question says that two charges 5 into 10 to the power minus 8 coulomb and minus 3 into 10 to the power minus 8 coulomb are located 16 centimeters apart. At what points on the line joining the two charges is the electric potential 0? Take the potential at infinity to be 0. Now we know that the notion of potential says that the electric potential V at a point P due to a charge Q at a distance R is given by V equals to 1 by 4 pi epsilon naught multiplied by Q by R. Here this is K, that is Coulomb's constant, and K times Q by R. Now the net potential energy due to multiple charges is the algebraic sum of the potential due to individual charges. So potential energy of a system of charge is just given by algebraic sum of individual potential on that point. For example, if Q1, Q2, Q3 are three charges and they are separated by a point P by the distance of R1, R2 and R3 respectively. So Vp, or the potential due to this three system of charges at point P, would be given by the algebraic sum of the individual potential. Now the question said that two charges Q1 and Q2 are there. Q1 is of positively charged, that is 5 into 10 to the power minus 8 coulomb, and Q2 is minus 3 into 10 to the power minus 8 coulomb. We have to find out the point between the line, or the point on the line joining these two charges. So let us assume that there is a point P over which the potential due to these two charges is 0. Now as we have studied just now that potential due to a system of charges is the algebraic sum of the potential due to the individual charges. So we will find out potential at point P due to Q1 and Q2, and we will sum it and we will equal it to 0. Now solving this equation, we will find out the value of x. Now by the value of x, we will get the point at which the potential due to charge Q1 and Q2 equals to 0. Now similarly, proceeding with that strategy, we see that potential due to charge Q1 would be equal to KQ1 divided by x, and potential due to charge Q2 would be equal to KQ2 by 16 minus x, because if this is x, then the total distance is 16 centimeter, then this distance would be 16 minus x, or 0.16 meter minus x. Now proceeding with the calculation, we will get the value of x as 10 centimeter, that is 10 centimeter away from point Q1, the potential due to these two charges would be equal to 0. Now there would be another case where the point may lie outside these two charges on the same line. So let us take the second case as like this. Q1 and Q2 are here, they both are 16 centimeter apart, and let us assume that point x, the point P at a distance x away from the Q1 charge on the side of Q1 charge. Now proceeding similarly like before, we will get the equation. Now after solving this, we will get the value of x to be minus 0.4 meter. Now minus suggests that, so since we have taken this distance as our desired assumption that the potential at this side would be 0, now we have got the value of x as 0.4, minus 0.4. So minus suggests that this point lies on the other side of the charge and by 40 centimeter away from this point Q1. So 40 centimeter away from Q1 on the right side would be somewhere here. Now 40 minus 16 centimeter would be 24 centimeters. So 24 centimeter away from charge Q2, or 40 centimeter away from charge Q1 on the right side. Thank you.